So how you do B2 using the calculator. You need to add a new problem, so doc insert, which is for one problem. I'm going to define the function first on the calculator. So the function is x cubed minus 5x squared minus 3x plus 1. And that's what the function looks like. Determine the values of x for which the function fx is decreasing. Leave your answer in terms, correct 3 sig figs. So I'm going to add a calculator. I'm going to use the derivative function, which I've shown you how to do many times. The function is f1 of x. That's what it is, the derivative of that. I'm now going to solve this. Now there is more than one way of doing this. I'm going to show you both ways. Now we must make this equal to 0 we make this equal to 0 because this is where the turning points are, when the gradient is 0. Push enter. Now, oops, what am I doing? My mistake. I put 0 rather than x. So I'm just going to go back into here, change that to an x and push enter. Now it says it wants to have these as a decimal, so do control enter with that. On my calculator I've got to do it slightly differently. I'm just going to go to number, convert to a decimal, and click enter, and that's where you get your x values from, and then you do everything else. If I wanted to go back one and do it a slightly different way, I could go back to the graph, click go to analyze graph, maximum, left of it, right of it, and that's how you get the coordinate point there. If I go back to that, because it says it wants the coordinate points, what I can do, well, it doesn't actually ask for the coordinate points, does it? It just says what's the x values. If I wanted to have anything more, I could type in f1 and I could open the brackets and just type in, say, 3.61032, and that gives me the y value for that second point there. Part B, consider the transformation. So all I do is I say find f, oops, for some reason I had a caps lock on, which I don't want to have, f1 of x. Now, to do this, we need to do x minus 5, and then we need to just do plus 3, and I push enter, and then forget to put a g of x in front of it, and that's it done. So you find it. Part C, by using the calculator, determine the two coordinate points, x, y, where the function has a gradient of 5. So we just do, I'm actually just going to do, go back up here, copy that down. This time I just put 5 rather than 0 because the gradient's 5. Push enter, and that's my two values. I type in, but I need to have what the y and the y values are. So I type into my calculator f1 open brackets minus 2/3 and f, I don't know why it's some capitals there, f1 and 4, and then I get the two coordinate points. I'm done.